Hello, good people. Here we are. We're going to make this the last video of this section. I am going to ask you to maybe do some of these on your own to kind of practice, and then we'll review them when we see each other again. I definitely want to do example 5. I was going to skip number 5 and go to 6, but example 5 offers us an example with a trig function. So maybe we should do that. Also, I think I lost my pen. So where did I put my pen? Got it. Okay. So example 5, we have a function k of x. K of x is 2 sine x minus x. Find the intervals where k of x is increasing or decreasing as long as those x values are between 0 and 2 pi. So why do they give us this? Why do we get that condition where x's that are between 0 and 2 pi? Well, since we're dealing with a trig function, we know that trig functions have zeros or solutions in infinitely many points, right? Because you can keep going around the unit circle, and get more and more x values or angles that will find those values. So they're saying, hey, let's just worry about x values or angles that are between 0 and 2 pi. So step 1, find the derivative. That would be 2 cosine x minus the derivative of x is 1. Done. Step 2, is the derivative ever undefined? Well, 2 cosine x minus 1, that's a trig function. That's a wavy function. That's not undefined at all. It's always defined. So really, I'm just going to set it equal to 0. Great. Let's solve for x. Well, I'm going to add 1 over. I'm going to divide by 2. Can I do that in the same step? I can. Are you okay with that? Because I just did it. So I added 1 over, divide by 2, and I got to this point. Hey, this looks like those examples on our warm-ups. Cosine of what angle equals 1/2? Let's see. X equals 1/2. When does it equal 1/2? I believe it equals 1/2 whenever x equals pi over 3. I almost got the wrong one. Pi over 3. And it also equals 1/2 when x equals 5 pi over 3. At these two angles, the cosine of pi over 3 is 1/2, and the cosine of 5 pi over 3 is also 1/2. I find my critical points. Yay! So now let's build our sign chart. I have my x values, pi over 3 and 5 pi over 3. And these are special because k prime is 0 at these 2 points. But now we're going to check points around them. Okay. Let's check points to the left of pi over 3. How about pi over 2? I'm sorry, pi over 4. Pi over 4 is less than pi over 3. And I want to know what kind of answer do I get when I substitute pi over 4 into my derivative. So that would be 2 cosine pi over 4 minus 1. Pi over 4 is square root of 2 over 2. But if I multiply times 2, that's just going to give me square root of 2 minus 1. So the question is the square root of 2 bigger than 1? Because if it is, this is going to be positive. Or is the square root of 2 less than 1? Because if it is, then this is going to be negative. It is positive. Actually, square root of 2 is about 1.4. Is that right? And we got all the positives there. Again, I could have chosen any number between 0 and pi over 3, and I should be getting this answer. But let's choose a value in between pi over 3 and 5 pi over 3. What about pi? That's in between. Let me use a different color. And if I use pi, let's see what I get when I substitute pi into the derivative. Cosine of pi. Well, cosine of pi is going to be the x-coordinate of pi, which would be -1, times 2, that's -2, minus 1, that's -3. And so I have a negative answer there. But I could have chosen any value between those two black critical points, and it still would have worked. So now the last part, let's pick a number on the other side. What color should I use? What about 11 pi over 6? That's bigger than 5 pi over 3. So now let's do 2 cosine 11 pi over 6 minus 1. Well, 11 pi over 6 is going to be square root of 3 over 2 times 2 minus 1. Well, these are going to cancel, so I'm left with square root of 3. And if I take square root of 3, which is about 1.73, minus 1, I am going to get a positive. And I can choose any other point, and I'll be done. Great. I can definitely see where my original function k is increasing, decreasing, and then increasing again. I can also tell, just to kind of lay the groundwork, that at pi over 3, I think I have a maximum point because I see a hill forming here. And I think that at 5 pi over 3, I have a valley or a minimum because I see that forming here. But that's for the next section. But I want you to start to think how the sign chart can help you figure that out. All right, let's see. Where is it increasing? So k is increasing on the interval between. Now remember, they told me that the starting point should be 0 and the ending point should be 2 pi. So x's that are between 0 and pi over 3. It's also increasing for x's and x's that are between 5 pi over 3 and 2 pi. So there is an ending point here. That would be the 2 pi. There is a starting point. That would be 0. So I have to say between here and here, between here and here. And that is true because k prime is greater than or equal to 0. It is positive or equal to 0 on those intervals. And then k is decreasing on the interval. I don't know why I keep writing g. On the interval of x values that are between pi over 3 and 5 pi over 3. And I know that because k prime is less than or equal to 0. It's negative. And that's it. So we're using a lot of things here. We're using the fact that we know how to take derivatives. So that's step number 1. We're using the fact that we know how to find x value angles based off of the unit circle. That's step number 2. We are substituting values into my derivative in order to create the sign chart in step number 3 here. And I guess I should have numbered this as number 3, step number 3. And then analyzing what's going on in order to interpret the behavior of the graph, which is what Unit 5 is about. That's a lot, right? And so you can definitely expect one of the free response questions to kind of hover over this type of analysis, where we have to use the derivative and the second derivative in order to find some things out. We're going to do one more, and then I think we'll take a pause and get ready for the next section. Example 6. Consider the graph of f prime above. Where f prime is the derivative of f. Find the intervals where f is increasing or decreasing. So if I follow my process, step number 1, I don't need to do because they gave me the derivative. Okay? And so I'm going to say C graph. Step number 2 says find the critical points. So when is this graph, which is the graph of the derivative, equal to 0? Well, it's equal to 0 here, it's equal to 0 here, and it's equal to 0 here. So this graph is equal to 0 at those 3 points. That means f prime is equal to 0 at x equals negative 4, x equals negative 1, x equals positive 1. I'm doing this just to kind of practice the process. Step number 3, I can build a sign chart. I don't have to, but I can because I want to practice this idea that the sign chart helps you even if they give you a graph. And why are these special? Oh, because f prime is 0 at these places, right? I should also check, is the derivative ever undefined? But I don't see any undefined points. So now, when is the derivative? Oh, I pick a point to the left of negative 4, like negative 5. So at negative 5, is the derivative positive or negative? Well, I'm not talking about the slope. I'm talking about the derivative, which is this graph. This graph is positive. But then if I pick a number in between these guys, like negative 3, oh, it's still positive. Not the slope, but the graph, right? It's above the x-axis. And then I pick a number between negative 1 and 1, like 0. Well, at 0, my graph is down here, and the graph is the derivative, so that's negative. And then pick a point on the other side, like 2, and the graph is above, so that's positive. That means my original function f is increasing, still increasing, decreasing, and then increasing. Think about what you're doing. You're analyzing the behavior of a function that you don't have the graph of, that you don't even have the equation of, but instead they give you the graph of the derivative in order to analyze the original function. So you're kind of thinking backwards, right? They're giving you the derivative, and you're telling me things about the previous function that gave me that derivative and how it's behaving. It says, be careful using graphs. If the graph given is f prime, then f prime is greater than or equal to 0 whenever the graph is touching or above the x-axis. So basically they're saying in these sections, that's when f is increasing. And in these sections, that's where f is decreasing. And I think that's what we found in our analysis. So I'm going to say f is increasing on the interval between, let's say, x's that are less than or equal to negative 1, right? Anything over here, the derivative is positive. And x's that are greater than or equal to 1, anything over here, that's going to be equal to 0 or positive. Because the derivative is greater than or equal to 0. Done. F is decreasing between negative 1 and 1. And so I'll write it this way. And I know that because f prime is less than or equal to 0 or negative and 0 at those points on those intervals. And that's it. That's all we have to do. Let's try one more. And then I'm going to ask you to maybe try number 8. Number 8, you have to work it out and find the derivative. Number 9, you don't have to work out because they give you the graph of the function, so you can identify where it's increasing, decreasing. And then on number 10, it's kind of like the one we just did, where they give you the derivative, and you have to determine what the original function is doing in terms of that. However, I will say, be careful with number 10. They tell you g of x is f of x squared minus 1. So when you go to take the derivative on number 10, I got to do a chain rule here. And my chain rule is f prime of x squared minus 1 times 2x. And so that's the derivative that I'm going to have to use, because they're asking me about whether g of x is increasing, decreasing, not whether f is increasing, decreasing. So I got to use this formula as my derivative. But let's do one more graph, and then we'll pause this section. So let's consider the graph of g prime. So they give me the graph of the derivative, where g prime is the derivative of g. Find the intervals where g is increasing or decreasing. Awesome. Okay, so let's see. Can you find the derivative? Well, see the graph. You don't have to write that, by the way. I'm just telling you, if you're going to do the first step to find the derivative, you don't have to find it. Just look at the graph. Step number 2. Where's the graph equal to 0, or where's the graph undefined? Well, the graph is equal to 0 here and here and here, and the graph is always defined. Now, some of you might say, well, wait, what about this sharp turn? That is a sharp turn, you're right. So that means the derivative of this graph, which is the derivative, so the second derivative is undefined, but the graph itself, there's a y value for any point that I can imagine. So then those 3 points are your only critical points. And I'm going to label them as such. My critical points are those. Great. I can start making my sign chart. There's a critical point at 1, critical point at 3, critical point at 10. These are all x values. Why are they special? Because the derivative is equal to 0 at all of those. So now, think. Pick a point on the left side of 1, like 0. At 0, this derivative graph is positive, but I could have chosen anything else on that side. So then that means they're all positive. Pick a point between 1 and 3, like 2. My graph is under the x-axis. It's in the negative area or negative part. So therefore, G prime is negative. Pick a point in between 3 and 10, like 5. So 5 is above the x-axis. That means my function is positive, but the function is the derivative, so that means the derivative is positive. And then pick a point to the right of 10, and that would be, I don't know, like 11, and that would be in the negative part, so that means all of these are negative. So what is this telling me? That's telling me that the original function is increasing, then decreasing, then increasing, then decreasing. So in theory, I should have a maximum point, there's a hill, a minimum point, there's a valley, and a maximum point, there's a hill. But this question is about increasing, decreasing, so we're going to say G is increasing on x values that are less than or equal to 1 and between 3 and 10. X's that are between 3 and 10. I don't know why I wrote 5. Remember, the zeros are what we use to determine things. And I know that because G prime is greater than or equal to 0. However, G is decreasing on x values that are between 1 and 3 x values that are greater than or equal to 10. And I know that because that's where the derivative is less than or equal to 0. I can predict what the graph of the original function is doing, even though I don't have the equation of the original graph, nor the graph of the original graph, but all I have is the derivative graph. I can figure this out. And you can too. And that's what we're going to be practicing on the next time that I see you.